Alright, this is the last video on nitrogen nucleophiles. It's pretty short, but I didn't feel like this fit in real well with the other topics, and so I went ahead and made it a separate video. So going back to when we were talking about primary amines reacting with aldehydes and ketones, they made imines, where I ended up with a double bond between the carbon and nitrogen. And so we often represented the primary amines as RNH2. Well, it turns out the R group doesn't have to be an alkyl group. And in fact, it could be an alcohol, in which case, rather than having, a methyl group or an ethyl group or whatever coming off here, we have the OH that's left. Or we could have another NH2 group. And so we get the NH2 here as opposed to the OH in this case. And this is the one that I'm actually interested in. This product where I have the carbon-nitrogen double bond and then another nitrogen-nitrogen bond is called a hydrazone. Now, if you're interested, the mechanism for the formation of these two compounds is exactly the same as the mechanism that we looked at for a ketone or aldehyde reacting with a primary amine to form an imine. The only difference is, rather than this being some R group, it's an OH or an NH2. It's not really involved in the mechanism. Now, the reason we are interested in the formation of this hydrazone is because we can follow it up with a reaction of a base like potassium hydroxide and heating it up, and it'll actually pop these guys off in an elimination reaction. And so this two-step process where I first do a reaction with this hydrazine to form this hydrazone, and then in the second step when I hit that with potassium hydroxide, that gives me a two-step process for reducing a ketone into an alkane. And so this could be potentially useful for our synthesis toolbook. Now, the book does show the mechanism for this reaction, but I'm not going to make you responsible for that. You just need to know if we hit a ketone with hydrazine, then potassium hydroxide and heat, we can reduce a ketone into an alkane.